webinar. As I mentioned, title is the open source, essential for modern application delivery. First, I want to also thank CloudBees for sponsoring today's webinar. And in the past, they've brought us some of our best, so I'm sure this will be no different. Our two panelists for today are Jeffrey Hammond of Forrester, who's Vice President and Principal Analyst at Forrester, and prior to that is a software development veteran with more than a few years of experience, let's leave it at that, in software development and delivery. He handles their at Forrester, he's working on Agile and DevOps practices, as well as open source policies. Our second panelist is no stranger to our DevOps.com audience. Also fantastic speaker. He presents at our DevOps Connect events as well, and just an all-around great resource for DevOps and OSS open source software, and that's Brian Dawson. Brian, welcome. Brian's now recently at CloudBees, as he's worn many hats there, but he's DevOps Evangelist and open source software marketing manager. Prior to CloudBees, Brian has also spent a few years in the software business, leading agile transformation consulting practices and implementing CI/CD and DevOps. So, gentlemen, Jeffrey and Brian, welcome.
Thank you.
Thank you.
Just want to make sure you can hear me, guys. Yes? Okay,
Absolutely.
There's our sound check. And let's move on to our next slide now.
Okay.
And
hey,
I'm going
Alan,
to hand things over to Jeffrey to get started.
Yeah, Alan, I want to thank you very much for being very kind there in terms of describing my tenure. I guess I'd say I'm old. But you know what? I will say, go ahead. I'm sorry. I'll say that being old and in this industry and having built development tools and having sold commercial enterprise development tools, especially for application lifecycle management and release management, gives you a certain amount of perspective. And I want to do that today. I want to share some of that perspective. And in particular, my goal is to give those of you that are wondering what role open source plays in DevOps, or maybe even better, you know how important it is, but sometimes you have a challenge convincing your management or your VP of application development or your CIO the role that open source tools and frameworks have. I'm going to give you some data to use as you try to make that case for why you think these tools are a key part of your strategy. But first, I want to start with a little bit of a shout out, an anniversary. As somebody that's been in this space for a long time, it's kind of easy to lose track of modern technologies and just how long they've been around as well. So just this next week, we're going to be celebrating almost a decade or maybe a little bit more of what I consider to be some of the most seminal technology advancements when it comes to the modern way that we develop applications. And I want to call some of those out. So first of all, next week, we'll be celebrating the 11th anniversary of Amazon releasing S3 to developers as a public service that they could build on as part of their public cloud. And it really kind of changed the way that we think about infrastructure. And we've gone all the way from having to have spare development machines under our desk where we installed our test environments so that we could run our applications to the age of serverless computing in the public cloud. The second anniversary, I think, is just as big, maybe even a little bit bigger. It's hard to tell, but we're coming up in June on the 10th anniversary of the iPhone. And I remember seeing this at Forrester. I was covering application lifecycle management. The iPhone came out, and it was very clear to me that mobile development was going to change forever, that we were going to go from mobile as something separate that a particular type of developers did to development that was much more like the web applications that we were building. Now the apps that we're building, it essentially took mobile application development mainstream. And now most of our clients are at the state where the majority of their customer traffic is coming from mobile devices. Mobile plus cloud, it's been a heck of a run over the last 10 years. Essentially, we are seeing that in the way that clients are spending in IT. This data is from a friend of mine, a peer of mine, Andy Bartels. Every year he does a sizing of the U.S. market and the various growth rates of different types of software licenses and spend. And although you can't quite say that cloud subscription fees have bypassed the combination of new software license fees plus existing software maintenance fees, it's getting pretty close. You're at about 74 billion a year versus 56 billion a year. But look at those growth rates. Still double-digit growth rates for cloud subscription fees, where you're looking at single digits for software license fees and maintenance fees of existing software, support fees, slower growing. I think it is fair to say that the lion's share of growth in this market when it comes to people using commercial software is certainly going to the cloud. Now, why is that? I think it's very simple. You know, I think about my early days back when I was still wet behind the ears in the startup space, and I remember when we got our first $10 million round at Rational Software. What did we do? We immediately went out and spent a bunch of that on commercial software. We went out and spent a bunch of that on Solaris boxes, and then we took the rest and we put it into our enterprise sales force so that we could take our software development tools, move them forward, give the developers the tools they needed to build, and then go out and sell it in the enterprise services market. If I think about how we sell software to enterprises today or services, completely different. I would tell you that I think the cost of innovation with software today is probably about 10% of what it was back when I was building development tools on a day-over-day basis. The reason for that is exactly what we looked at before. The combination of public cloud infrastructure, the combination of open source software, the combination of new ubiquitous clients for the applications that we build. At Forrester, we talk about these as modern applications. And we see that there are 7 traits that are driving that reduction in the cost of innovation and the ability to go out and be successful with software. Omnichannel clients everywhere, tablets, mobile devices, browsers, even client software, chatbots, embedded Internet of Things type devices, all deployed with a background of elastic infrastructure. So the public cloud is great, but it's really the scale out capability there and the scale up and scale down capability that drives a lot of that cost reduction in terms of innovating with new software. These systems are increasingly built with discrete services using managed APIs. Now we're looking at things like serverless and microservices, built on an ability to get measurable data, feedback, and analytics from those systems. Now, those 5 are pretty self-evident to any modern developer, but sometimes I feel like people miss the last 2 items on this list, that these modern applications integrate open source everywhere. It's ubiquitous, it's pervasive, and there are some reasons for that. And then finally, in order to reach the level of speed required, given the lower costs and the ability for anybody to go out there and innovate and disrupt a market, the ability to go fast by employing DevOps techniques. And while I could spend a lot of time on the first 5 things here, I want to spend the rest of my time with you today on the last 2. From a data perspective, we see this in the way that developers are using open source. Every year we go out and we do a survey at Forrester of developers, about 2,000 developers worldwide, and we ask them a number of different questions. One of those, and this is a subset of the responses, is which of the following classes of open source software development tools or frameworks have you used for development or deployment in the past 12 months? So active use. The important thing here is the figure at the bottom. Only 1 out of 8 developers has told us that they have not used open source for development or deployment in the last 12 months. And that includes all those Microsoft developers that are out there in the world. Even with those folks, they are using open source as part of their go-to-market efforts. And it's not just for the software that they are shipping into production, making available to customers and employees. It is also the software that they're using to deploy that software. When we ask developers how prevalent are open source software development tools in your delivery pipeline, 16% say that they play a major role. They are almost exclusively open source. 42% say that it plays a significant role. Over half the tools in the delivery pipeline are open source. 37% say it plays a medium role. They use it, but it's not quite half the tools in their delivery pipeline. Add all that up. 19 out of 20 developers say that they are using open source in some way, shape, or form to deliver the software that they put into production, which itself is open source. Now, why? Why does it matter? Well, some of the reasons that we see, first of all, we find that firms are increasingly attracted to trading the capital expenditure of traditional enterprise software, buy it up front, and then expense it at 20% a year thereafter, with an OpEx model, an asset-light model, where they can subscribe or they can simply pay the equivalent in support costs or lower support costs. Operational expense tends to be attractive to many different types of businesses. From a technical perspective, though, we find that many commercial software models still don't do a good job coping with the elasticity of the cloud. Say, for example, you are in a retail environment and your biggest sales day is sometime in November, and you've got all of your services up on the cloud, and you need to spin up 1,000 compute containers in order to support that demand load. You don't want to necessarily have to buy commercial licenses to support all 1,000 of those instances for the entire year. That lack of elasticity of commercial software models really inhibits them when developers go out to choose technology. But it's not just about the licensing model, it's also about the attractiveness. One of the things that we do is we survey developers and we ask them how they choose technology, and they are most likely to choose technology when finding out about it from their peers, or when being able to look at it themselves and spend time hands-on. Well, open source tends to help in both of those situations, because one developer can tell another developer about it very easily, and you can download it, you can look at it, you can work with it, prototype with it. It's easy to get hands-on experience. And as we see the rising tide of a developer shortage in the United States, the Bureau of Labor Statistics estimates that between 2014 and 2024, we're going to need about 500,000 new developers. It's barely, the colleges and the comp sci majors are barely producing enough to meet that demand. We are finding that development managers and VPs of app development or VPs of infrastructure are tending to defer to their developers a little bit more, especially the ones that they want to keep and retain over time. It was expressed to me very well by a friend of mine who works at Netflix a number of years ago, that they try to hold the line on standardizing tools for teams, but for individual developers, they are willing to defer a lot of latitude to them for the tools that make them productive, because of that increasingly social nature and increasing demand for developers. We also find that the speed of acquisition and deployment of open source tools makes them more attractive for the modern developer. As a result of increasing interest in open source, we see innovation shifting, and we'll talk a little bit more about that in a minute. And then the final thing is we see a new generation of millennial developers come into the workforce. They are just used to working with open source, and they will exhaust every open source alternative first before they consider a commercial replacement, because they've been brought up working in this very social environment. I want to go back to that acquisition process for a second, because if you look at traditional acquisition processes, CMMI acquisition is a good example. What you find is that they tend to be very slow. There are folks from the purchasing organization involved. Often an RFP has to get fielded. You have to look at multiple vendors. You have to involve them in bake-offs, and it's not uncommon that you see 10 to 12 weeks or more between the need first emerging and then a candidate tool being selected. Unfortunately, in today's environment, where we're seeing 8 to 12 deployments of mobile apps a year, we're seeing technology evolving very quickly, this sort of long-term process is just really too slow. It's not agile enough, and that tends to shift things in favor of open source. In particular, we find that developers would much rather go hands-on themselves than deal with purchasing or procurement folks, let alone lawyers, as part of a contract that needs to get put into place for commercial software. One of the other things that we find is when we get to deployment pipelines, the amount of waste that's involved when you have to stitch together multiple tools, and more importantly, you don't have control over the source code for those tools. You are dependent on the vendor for their integration capabilities. Those sorts of things tend to lead to a lot of waste. I remember when I was developing tools in particular, and we would deliver our code and then maybe rebase it, and we would have multiple build environments, and then we would have testing tools, and the level of integration, the pain of going from stage to stage, whether it was manual builds or manual test cases or meetings to talk about the test cases failing or deployments not working right, there was just a lot of impedance in our processes. If you have complete access to the code, you can do the integrations, you can build on things, you can work with the community who may have the same sort of connection needs and integration needs that you have, we find that it's a lot easier to knock some of this sort of waste out of a typical build process. So one of the things that we are finding with modern applications is that it's really, really important that you have control over how often you release. You don't necessarily want to release all your applications multiple times a year, 10 or more, but for the front ends, the mobile apps, for the APIs that your clients are working with, for individual microservices that are iterating very quickly based on customer demand, there is the need for delivery speed to vary. I often use this concept, the Kinefin framework, with my clients in describing why that's the case. When you are involved in early stage development, you may not know what you're doing, and you need to engage in a probe, sense, and respond type of release process. You admit you're not quite sure what needs to happen, but you're very, very able to find out very, very quickly. Build tools and delivery pipelines have to be capable of delivering at that rate of speed at the same time that they have to be able to deliver with more traditional processes, with slower processes, with higher governed processes. Now, the problem with that is that a lot of commercial tools haven't necessarily kept pace with the types of innovations required for a probe, sense, and respond, rapid delivery, modern application pipeline. What essentially happens here is what I would call the parable of the Honda and the Cadillac. If you think about a Cadillac, great car. Everybody would maybe like one if they could get it for a very low cost. Lots of features, power windows, moonroofs, all that kind of thing. But a lot of us, buy Hondas. Why do we buy Hondas? Well, they provide basic transportation. They get you from point A to point B. They tend to get the job done. Now, the interesting thing is that the types of people who buy Cadillacs always want more. They want more features. They want more capabilities. They want the best possible car that they can have, the highest luxury car, and that puts pressure on the Cadillac manufacturer. They need to continually add more, which drives the price up. They have to invest in that high-touch experience. The same thing happens in the delivery market when it comes to deployment tools and DevOps products in the commercial space. There's always this pressure to do more. At the same time, we find that much like Honda's, open source tools that may have started out as good enough because of the community involvement tend to get better over time, and we tend to see higher quality as defects are fixed by the community. One of my favorite sayings in the open source space is all bugs are shallow. When you've got many eyes on the defects, it's a lot easier for those defects to get fixed and addressed, especially if there are multiple users of the frameworks that have that need. This creates an interesting effect because either the Cadillac products get out of market from a price performance perspective, or trying to drive profit out of them gets them to a point where maybe the quality starts to suffer a little bit because of the pressure to deliver new features, and you hit what's called the substitution zone. In market after market where open source begins to dominate, we see this happen. The open source products become good enough, high quality enough, their innovation rates start to move faster, and at that point, we can see massive substitution, sometimes on the order of 18 to 24 months, where the market will shift. We saw that happen in the IDE space with Eclipse. We saw it happen in the SCM space, first with Subversion and then with Git. And what our data tells us is that is happening in the deployment space, in the DevOps tooling space. Why is that? First of all, the nature of the types of innovations that modern applications and rapid delivery are driving. These are some of them here. The move from infrastructure as art, custom-built deployment world environments and compute, to infrastructure as code. The movement from big batch work, released a couple times a year, to small batch work, released on a continuous basis. The move from manual builds to continuous integration. The move from manual testing to automated API-driven testing to test all these emerging microservices and web services and service calls. The move from integrated architectures to loosely coupled services on top of those APIs. The shift in focus from maximizing the individual productivity of developers, testers, ops folks, to maximizing flow and cross-skilling organizations as they begin to become more agile and move to smaller teams. And then finally, the move from 100-page requirements documents to testable hypotheses, and the move to analytics and real-time data collection on these applications that are deployed into clouds. As a result, what we are seeing happen is that the traditional Cadillac world of the commercial tools and the need to do plan, align, build, test, ship, and do that faster reaches a point where that sort of process, those sorts of tools, and what they have focused on simply cannot move any faster. We move to parallel release environments, we move to small batch delivery, and it's a different type of capability that is required here. Testing, as an example, just doesn't work if it's not highly automated as we move to this sort of rapid delivery environment. That amount of innovation plus the dramatic difference in how we release faster creates an innovation gap, and it creates that substitution effect. We see this when we ask developers about commercial software development tools. When we ask them about open source and the level of innovation, we find that 11% say that open source is going at a much faster rate, 44% say that it's going at a faster rate, 29% say that it's going at a similar rate. So add those numbers together. 59, almost 84%, so more than 8 out of 10 developers say that open source is moving faster or at least as fast as commercial tools when it comes to development. So faster innovation or equivalent innovation. When we ask about quality relative to commercial software development tools, the new capabilities of open source tools are of much higher quality, 13%, of higher quality, 39%, of the same quality, 37%. Again, almost 9 in 10 developers. So when 8 in 10 developers say that the innovation is at the same speed or better, and almost 9 in 10 developers say that the quality is at the same level or better, you've got that inflection point. The Hondas are essentially taking over from the Cadillacs in this market. Now, I just want to take a couple minutes here at the end and give you a little bit of advice. If you're going to take this data and use it to go make the case that you should be doing more with open source tools, it doesn't necessarily mean that you should be doing it without help. I love this quote from the CTO of a travel organization. I book travel, airline flights with them on a regular basis, but it sums up how folks that are new to using open source at scale strategically should think about their adoption efforts. Our acquisition of open source is driven primarily by the desire to avoid software costs wherever possible, but we always buy product support because it's less costly than supporting open source projects ourselves, certainly at least in the short term. Now, while that travel provider will evaluate on a yearly basis whether that's the case, they generally find that the first 3 or 4 years of using a tool that tends to hold pretty true, or a particular piece of infrastructure. Now, why is that? That is because there are a certain amount of integration costs that open source brings with it. Installing it, getting it to run, linking it to the other pieces of software, especially when it comes to development and deployment pipelines to drive flow through the systems. We find that about 18% of developers say, yeah, not necessarily a problem for us. It integrates easily without customization. But the other 82% either acknowledge that some customization is needed when it comes to integrating open source with their tools, or almost 1 out of 4 say that extensive customization is required. Now, if that customization can be done once and then shared by the community or by clients, as opposed to again and again at individual customers, you can get benefit from using a mixed source solution or a commercial solution on top of the open source product itself. We also find that when it comes to open source, much like with commercial software, security tends to be a concern. In fact, it's the top concern, and this hasn't changed since I started looking at the data in 2008 when it comes to open source. When we then look at how satisfied folks are with the security capabilities of their open source tools, we find that there's still some fear, uncertainty, and doubt out there. So that will be one of the reasons that we find that clients will often turn to some sort of third party that can help them feel more comfortable with the security of the tools that they are using. Finally, this idea of mixed source, commercial on top of an open source core and open source capability is something that can add some fairly significant value, and we find that about 54% of developers think that that is indeed the case. Now, what? Improved quality, faster bug fixes, or bug fixes that get backpatched to earlier releases so you don't necessarily always have to be on the latest release, a richer feature set. We find that in things like Red Hat with Enterprise Linux, or Mongo with the administrative features and clustering capabilities that they create on top of the core database. Somebody that's actually contributing or helping to move the community forward, helping with plans, that sort of thing. We see that in the Drupal community with a company like Acquia. There are very good reasons why this combination of open source and commercial on top of that open source has proven to be a very viable win-win for both consumers and producers of open source projects. So I want to thank you for listening to me. Again, hopefully you can use some of this data to build your case for more strategic adoption of open source in your development tool space. What I would leave you with is, it's going to happen. So if you're skeptical, we'll be having this conversation again, and it's only going to get more and more necessary for you to figure out your open source strategy. Make sure that you have a comprehensible policy that says why you're using open source, what licenses you're comfortable with, and how developers can make sure that these tools get brought into your organization. Define your support strategy, how you're going to support. Are you going to self-support, go to try to hire people from the community, use an SI, use a vendor? Somehow you're going to have to support your tools. It's not magic. Understand that these Honda markets are out there. Concentrate your adoption efforts in the markets that are the furthest along in massive substitution from the commercial products that maybe were part of the last generation of tools. For the products that you find strategic, consider becoming part of the community, maybe even contributing back with documentation, with bug fixes, with new features that are useful for your own organization. And then finally, even the best organizations, I've been part of them, will sometimes run afoul of viral licenses like GNU. Make sure that you have a process in place that stipulates how you are going to deal with the inevitable challenge that requires you to remediate code that you may have inadvertently linked and created license exposure for your organization. So with that, I want to thank you very much, and I'd like to turn things over to Brian to talk a little bit more about the how of open source in the delivery and DevOps market, and in particular how CloudBees helps make this a reality.
Excellent. Thank you, Jeffrey. And as someone noted in chat as you were talking, this is amazing information. I think we all understand, if we're in modern software development, we all have experienced and come across and benefited from open source, but this information that you put forth has sort of allowed us to quantify it and get a more clear perspective on how it impacts our ability to deliver software in today's environment. So I'm going to talk to you a bit about scaling open source in a DevOps or continuous delivery and DevOps environment, such that you can build better software based on open source innovation, but addressing some of the issues or concerns with open source that Jeffrey called out. Before we get started, I want to take a quick poll. And so if Jules, if you're able to bring the poll up, That would be great. So, what I want to ask is, as potential, assuming you guys are either adopting open source or interested in open source, I'm curious in understanding what is your process maturity. So how would you characterize your organization's adoption of continuous integration and continuous delivery? One, you guys have not adopted CI or CD. Two, you practice CI and have adopted it, but you are not yet formally practicing continuous delivery. Three, we have implemented continuous delivery on some of our teams, but it's not prevalent throughout the organization. Or four, it is prevalent. We've implemented continuous delivery on most to all of our teams. The poll will be open, I think, for 30 seconds or until we get 75% of the votes in, whichever comes first. All righty. So this is interesting. We see that 13% have not adopted CI or CD. They haven't started really on the automation and process improvement that is driving today's modern development. We have 27% that practice CI but have not extended to CD. And I think sometimes if we look back and we talk about some of the difficulty that people are experiencing with understanding and integrating some of the solutions available in the market may be part of the problem with extending to the right to include CD. And then we have what I think is most common to me and speaks a lot to what Jeffrey talked about. We have 39% of the respondents have implemented CD, but only on some teams, whereas only 20% can claim to have implemented CD on most or all teams. Thank you for that information, guys. In a minute, I will explain a little more about sort of how that maps to. Let's see, we can resume slideshow here. I think I have control to go ahead and do that, Jules, or maybe not. Jules, if you could go ahead and start the slideshow back up, that'd be great. Oops, look like we might be. So while that's happening, so Jeffrey highlighted a couple of things, and I'll repeat them, and then I'll transition on what we're going to cover. Modern software development requires rapid innovation in order to stay competitive. We're achieving that via implementation of continuous delivery and DevOps, open source tooling, and its ability to innovate rapidly and prioritize needed features or innovation over monetization has been the fuel for the modernization of software development and delivery. However, it has sometimes presented problems when trying to get a connected process flow, even at only team level, but then it encompasses or encounters additional challenges and difficulties when you try to scale to the enterprise. So I'm going to take a moment to frame some of those scaling issues and then talk about how we overcome those. But first, to sort of frame this up, if we look at where we're at, to summarize the picture I just talked about, our current state of development and delivery in a number of organizations looks like an intersection in Bangladesh, right? It's jammed up. It's not efficient. We're not necessarily moving at speed. And what we're looking to do as modern software developers is adopt new processes, practices, and in the context of this discussion, tools, so that ultimately we can drive at speed and at pace as we see in the lower left-hand picture. But in reality, whether using commercial or open source tools, we have to do a certain level of custom integration and implementation so we can have a solution that is best fit not only for a single team, but can accommodate the varying needs of all of the teams in our organization. So, at the end of the day, we're looking to take process and tools, sort of pimp our ride if we will have, but then get a fine running machine that will allow us to operate at speed. Fundamentally, what we're trying to do in adopting the software and these new processes is ensure that we can develop better software faster, going from concept to customer, continuously ensuring quality and value, so that we can eliminate waste, deliver software rapidly, and hopefully lead our markets in innovation. And if we look at recent data that we've taken from the open source community that CloudBees is closest to, and that's the Jenkins community, we can see that open source is fueling this market transformation. So for instance, 75% of organizations that we surveyed in our 2016 Jenkins community survey practice continuous delivery with deployment to production. Some of those, 50%, are using Jenkins to support manual deployment to production, but a not inconsequential 21% have a fully automated deployment to production with the potential that they're actually practicing continuous deployment. So continuous deployment of their production software is built on a platform such as Jenkins. Again, Jenkins or open source or mixed source leading innovation. We can also see that if we survey the same group, 61% are deploying very rapidly, meaning once or more per week. And in fact, we have 23% or 27% if you add the once per day that are delivering changes to production multiple times per week, which give them competitive advantage, again, fueled by open source. Now, to frame the discussion on the challenges of scaling such implementations to deliver at speed across your entire organization, I'm going to introduce you into 4 quadrants of enterprise CD and DevOps. Right? These are based on one axis tracking the standard steps in software development and delivery. So on the left-hand side, we have upstream development practices like define, plan, code, build. On the right-hand side, we have downstream delivery practices such as automated functional testing, release, deployment, and operation. On the other axis, we have the scale or the penetration of these practices at team, work group, or enterprise. Now, if we take some industry data here, we can see that 33% of organizations claim to have implemented Agile upstream. In the context of this conversation, this largely maps to our respondents, the 27% that said they practice CI but not CD, plus the 13% that said they have not adopted CI or CD. They would tend to be in this left-hand side. Now, data also shows that only 22% have managed to scale those practices across the organization. We also can look to downstream delivery, which is facilitated by continuous delivery. This is a case of organizations that have implemented continuous delivery, connected development to delivery in an automated way, but they have only done it on some or a few teams. They haven't scaled it across the organization. Data shows that our audience is a little bit beyond the market here because we're finding that only 13% can claim to have done this on some or a few teams. Now, where we want to get is enterprise DevOps, where we are implementing Agile upstream and Agile downstream practices across our entire organization so that we've achieved enterprise continuous delivery and DevOps. Now, we want to get here, again, because this has been proven to enable organizations to innovate faster, respond to market challenges, whether that's new technologies, whether that's security issues, so that they can gain and maintain competitive advantage. But sometimes we ask why, if this is so valuable and it's been proven and it's recognized, why isn't everybody there? Because in reality, this requires that you cross the inherent chasms between upstream and downstream on the 3 planes of what I call the DevOps Trinity: people and culture, process and practices, tools and technology. And there are some inherent differences, right? The culture upstream is to move fast and innovate. Downstream, maintain quality. The process and practices upstream are focused around moving faster and delivering faster. They use techniques like lean development, Scrum, Kanban techniques. And when we look at tools and technology, it's upstream where open source has really initially taken hold, because it supports the move fast. It supports these iterative methodologies. So we see rapid adoption of point solutions, starting at grassroots, bottom up versus top down, that support the rapid innovations in technology. But downstream, we tend to see tools and technology more focused on sort of enterprise class solutions, going through a corporate procurement process, the non-agile one, as Jeffrey outlined for us, with the belief that this is enabling more stability. So what we have to do is we have to cross these chasms to enable the transformation across our entire organization. So this is where we start to talk about the DevOps Trinity and tools. First, let's not forget, as we talk about open source tooling, that at the end of the day, that needs to support people and process. And all of these are equally important. But in order to deliver software more reliably and faster under the context of CD and DevOps, realistically, we require automation. Automation requires tooling. Tools are more quantifiable and usually easier to affect than people and the processes they use. So tooling, in particular open source software, provide an agile starting point and foundation for your transformation. But, there will be a but, that will cover scaling these implementations, have special needs and special considerations. So I'm going to make the case that we need to affect all three of the DevOps trinities, or DevOps in our organizations across all planes. But our best place for us to start, or the easiest, most quantifiable place for us to start, is going to be implementing tools and technology. And in fact, the first place that organizations are going to support this is to the open source world, but in consideration of the fact that they're ultimately going to have to deploy that open source within their organization. Now, to give you guys a quick break from hearing me talk, and to help me get some more information about your guys' world, I'd like to conduct another poll, and it'll be coming up in a moment here. The poll question here is, in your experience, what is your biggest obstacle in implementing continuous delivery and DevOps, either individually or in your organization? Answer one is it changing people and culture? So is it that soft qualitative thing of shifting people's mindsets? Is it implementing repeatable processes and practices, such as implementing Scrum or automated testing? Is it, as many have reported, is the problem there's a lot of great tools to do it, but how do I integrate tools across multiple groups so that we have continuous flow? Is it dealing with or upgrading legacy technology? Or is it other things like lack of management, support, budget, etc.? And of course, I'm going to assume that in most cases, everybody is affected by these things, but what is your biggest obstacle? Okay, and then let's just wait a moment. We have 55%. Hopefully people can tune in. The numbers are moving around, so I'd really like to get at least 75% response rate on this poll if possible. And Jules, if we can go ahead and try to keep it open a bit until it stabilizes, that'd be great. Okay, and it looks like we've settled in at 63%. Okay, this is interesting information. We found that changing 50% say their biggest obstacle is changing people and culture. 18% say the biggest obstacle is implementing the processes and practices, which is sort of sits between changing the way people work and operate, and then providing the tooling solutions to support that. 11% are having problems with tools integration. 8% are having trouble dealing with legacy technology, and 13% is its management, support, budget, etc. Thank you, Jules. So I'm going to go ahead and move forward to push through and talk a bit about the how. So how do we address this, right? When we talk about the obstacles in terms to process and practices and integrating tools, and in fact sometimes changing people and culture, I'll contend that tools and technology do enable crossing the chasms, but if you don't have the correct strategy to adoption of these mixed source tools, then they'll present problems. So there's certain attributes that you want to look for that are represented by some of the commodity open source tools that we see here. Jenkins, Docker, Nexus, or Artifactory, Git. You want to look to have normalized tools, right? They're language and practice agnostic, because you're going to scale these across different technology stacks, different teams with different mindsets. You also want to focus on these tools not being DevOps specific. And then, as we've noted, and as I think Jeff noted, if you take sort of the movement from rational clear case to Subversion to Git or distributed version control systems in the terms of SCM, you'll notice that we have to be prepared to rapidly pull and replace the best of technologies and also support adoption of different technologies across teams. This requires rich integration support and a modular approach that I consider tools as microservices. Obviously, we have to have a tool chain that supports tools and technology that support automation in a way that we can deliver software through our supply chain repeatedly with the ability to report and with flexibility to learn and adjust. We want our solution to increase confidence in downstream deliverables, so it needs to support a supply chain approach with features such as traceability, immutability, i.e. what I change upstream remains the same going downstream, and we need ability to measure and report, which is really key in being able to scale across the enterprise. When we invest in buying or developing and supporting software across our organization, we tend to seek to get the benefits of cross-domain visibility and metrics, security and governance, and we have to, as it becomes more mission critical, we absolutely have to ensure that we have a place to go for support in times of need. And if we were to look at a quick view of what I call solution soup looks like in a lot of organizations today, this would be an example where you have point solutions spread across the organization, and in fact this is a simple view of what you'd see on 1 to 2 teams, some addressing upstream, some addressing downstream, others really addressing issues at our enterprise level. And this is difficult to manage. And so what our challenge is to figure out how do we retain and support the flexibility of best-of-breed point solutions as are needed by individual stakeholders and teams, but organize it and integrate and automate across these tooling such that we can achieve continuous flow, but we can also tie it into our enterprise needs. We use our standard corporate authentication and authorization. We have a view into our entire portfolio. We're able to connect, say, downstream input such as what comes into our service desk back up front so that it drives our development. And ultimately, if we tie this back to our discussion of original needs, we need to integrate and automate in a way that we have continuous flow. We can implement supply chain management from the time that a code change has been made and a binary is generated to the time that it's deployed. We have rapid access to shared infrastructure, so we have like environments as we deliver. We're able to overlay security and access controls and achieve reporting analytics across our whole portfolio. And we need to be able to do this with the best of breed open source solutions that are driving innovation in CD and DevOps today. So with this, I'd like to take the last few minutes before we move into Q&A to talk a bit about CloudBees solutions that enable this. So first, an introduction into CloudBees. We are focused on open source. We are the Jenkins experts in that we employ the founder of the Jenkins project as our CTO. We have a number of people active in the Jenkins board and the Jenkins community, and we dedicate a significant amount of resources to helping drive the Jenkins project forward. But what we also do is we focus on the enterprise and what your business needs are, and we look to help you continuously deliver better software faster. We do this by taking an approach by building a commercial class, enterprise class solution based on the Jenkins platform. So we can use open source innovation to enable you to deliver software fast. In fact, to deliver software as fast as you could think of the changes that you need to make. So if you're not familiar with Jenkins, part of the real power of Jenkins is that Jenkins connects all things. It sits at the hub of your delivery pipeline to connect code and commit, to build and config, to enable scan and test, release and deploy, integrating to literally, directly or indirectly, to every tool out there that can facilitate these steps. We have a rich ecosystem of now over 1,300 plugins to enable you to connect to all of these tools that support this process. But some of the challenges with Jenkins, as Jeffrey highlighted with open source, is it was built to drive innovation and address specific needs. It's not focused on the enterprise use case of support, full security, easy manageability as we scale across an organization. And if we were to look at requirements for continuous delivery, they're going to map to this. We have Jenkins. That's going to help us sort of connect our upstream development to our downstream delivery. But as it supports our critical delivery process, we need to ensure that we have the knowledge and expertise to run it. We're adhering to security and compliance. We're able to operate at scale. And we have visibility across teams and stakeholders as well as across projects so that we can achieve enterprise continuous delivery. So what we'd like to introduce you guys to is our continuous delivery platform, which has been built on the leading open source solution Jenkins, but extended to solve the automation needs of an enterprise, which are scalability, security, manageability, and resiliency. So some of the features and benefits are CloudBees Jenkins Enterprise, or that you could take Jenkins and you can elastically deploy and grow your implementation on bare metal or cloud platforms so that you can minimize your hardware requirements. You can provide for a resilient system with high availability. It can install in minutes, and more importantly, you can allow teams to adopt and leverage the best of open source and Jenkins in seconds without having to go out, download, deploy, and integrate the solution on their own, all the while providing single sign-on and role-based access controls that integrate and tie into your enterprise authentication and authorization solutions. So we've built CloudBees Jenkins Enterprise such that it can deploy on a private or virtual private cloud, enable your shared services teams the ability to offer turnkey provisioning of continuous delivery solutions that provide for self-service to your project teams and Jenkins admins, and enable developers rapid access to continuous delivery as service. We've used containers and microservices to provide a highly elastic and rapidly scaling yet resilient infrastructure. And in particular, we've built this on this concept of what we call a distributed pipeline architecture, which provides the foundation for scaling on open source. So we all, I think, agree that CD and the tools that support it today enable speed. And when we're just addressing this for a single team, we're able to get the speed of a CD pipeline with little instability. But as we look to take a CD server and our open source solutions and scale those across multiple teams, our business risk and instability increases, and we oftentimes end up delivering slower than we originally were delivering absent continuous delivery. So our ability to deliver fast drops. With CloudBees distributed pipeline architecture, which is based on modern container technologies and a microservices approach, we're able to provide teams with access to independent, isolated, continuous delivery resources on demand. So they can onboard in seconds, and they can all adopt CD sort of safely without increasing instability. And in fact, we found that with distributed pipeline architecture, you can actually move faster than you would with just standalone CD. So we have customers such as Newstar that have gone from deploying once a day to 4 times a day, They're moving 4 times faster. Orbit is moving 5 times faster. Deployment times for Morningstar have gone from 6 hours to 40 minutes, so they're deploying 9 times faster. Overall, as we sort of survey the tasks that our customers have used CloudBees Jenkins Enterprise for in place of an open source solution, and we average their improvements, we found that CloudBees customers move 6 times faster than they do with no CD solution or CD based on a simple open source solution. So with that, I think I've managed to come in just in the nick of time, and we have about 5 minutes to take some questions. So Alan, over to you.
Sure, Brian. I don't think we actually have 5 minutes, but we'll do the best we can. If we only have time for one question, though, this is really the first question I wanted to ask Brian, or I don't want to ask, but it was actually asked by Samuel out in our audience, and I think it's a great one, and I'm going to throw it at both of you. Give your definition of CD, because I hear a lot of people confusing continuous delivery with continuous deployment. And I think that's a great question. It's something we run into a lot at DevOps.com as well. So Brian, why don't you go first on that? And,
yeah, I often hear this, and so we use CD, and people often think CD means continuous deployment. I view CD as meaning continuous delivery, and in meaning continuous delivery, it means that we are developing our software, continually testing our software, and validating deployments of our software such that with each change, our software is release ready, or we know that we can confidently release our software. But continuous delivery does not mean that we are continuously releasing our software. Whereas with continuous deployment, we are continually deploying changes to our customers in a production environment. So with each change, we institute an automated process that results in that change being delivered rapidly or near immediate or even immediately to a production environment.
I'll take a little bit of a different. I'll take a little bit of a different angle on it because I've had this argument with a number of vendors in the field about they talk about their DevOps tools, and I say you really should be talking about your continuous delivery tools, because I can have a conversation with a business person about the value of continuously delivering new capabilities to customers and to users, and they immediately see that as something that they would like and that they want and that has value. DevOps, it's kind of focused on developers and operations folks. So to me, I view the definition of continuous delivery in that way. It is the capability, having the capability from a software development perspective to deliver new features and new capabilities when they are needed by your business sponsors and desired by your customers. And that might mean you could deliver them twice a year because that's what your customers want. It might mean you need to deliver them as fast as you possibly can because there's a critical customer need for that capability. The capability to match your software processes to the rate of change needed by the business and and expected by the customer, to me, is the epitome of what continuous delivery is.
Excellent. Fair enough. Nick, guys, we're over already. All right. I'm sorry. I have to respect everyone's time. We're past the hour. We do have just one or two other questions, and I will get them out to both of you, and maybe we can get written answers out. Yeah, that being said, Jeff Hammond. Excuse me, Brian?
Sorry, Alan. Yeah, in regards to the questions, if you get them over to us, I think Jeffrey and I can collaborate to work on.
Be happy to take care of them.
Yeah, absolutely. One of the nice things about GoToWebinars, we do have written, and we have actually who asked them, so we can get them out. But Jeff Hammond and Brian, I expected no less of you. Jeff, welcome to our webinar family. You did a great job. Brian, as always, great job. Maybe we could delve a little deeper into this, because open source, especially in the DevOps and CI/CD space, is such a major part of what folks are doing day to day. But thank you both for appearing. For everyone who's still on, thank you for hanging with us today. We hope to see you on our next DevOps.com webinar. But until then, this is Alan Schimmel for DevOps.com. Many thanks to CloudBees for sponsoring today, and we'll see you all again soon. Bye-bye.
Thank you, Alan. Thank you, everybody. Bye-bye.